Manoj, please check if Kolle sir and Pawar sir are joined.
Good morning, Joshi sir. I have
Okay.
joined.
Yes, yes. Okay, great. And Ram, okay, Manoj, let us start.
Sir.
Sir will join, no problem. 10 minutes.
Okay. So, good morning. Honorable Pro Vice Chancellor of the University, Director of the School, Resource Person, Coordinator of FDP, faculty members, and all participants. A warm welcome to Faculty Development Program on Data Science, organized by School of Computer Sciences. Savitri Bahinabai Chaudhary, North Master University, Jalgaon, Maharashtra, sponsored by AICT, New Delhi, under AICT Training and Learning, Atal Academy. Myself, Dr. Manoj Patil, coordinator of the FDP, feel privileged to welcome you all once again on behalf of School of Computer Sciences, KBC NME Jalgaon. Dear participants, for the formal inauguration, we have with us Honorable Pro Vice Chancellor of the University, Professor B.V. Pawar, Director of School of Computer Science, Professor S.R. Kolle. Welcome, sir. Resource person of the first session, Dr. Ashish Tendulakar, machine learning specialist from Google Mumbai. Welcome, sir. Now I request coordinator of the FDP, Professor Manish Joshi, to give preface. Joshi, sir.
A warm welcome to all of you. And we are part of the world record. Like you all must be knowing that this Atal initiative, Atal online FTPs, have been created a world record last year by conducting more than 1,000 online FTPs and training to more than 1 lakh faculty, 100,000 faculties. And this year it is being even more. Like up till now, 1,400 plus FTPs have been conducted, and they are targeting 1,500 uh, are targeted for this year. So it's again a world record. So we should feel proud that we are part of a world record activity. So I welcome you all in such a big mega event where we are participating in a way in which we can enrich ourselves. So the FDP, this faculty development program, as we all have experienced such programs earlier also. So the AICT objectives of AICT has given its objectives and mission why they are conducting such a big events and such this big continuous activity. And the important objective is to empower faculty to achieve goal of higher education. So it's empowering ourselves, empowering the faculty. So large number of faculty and number of faculty members are there in various colleges and universities to empower them, to enrich themselves, to enrich them, and to increase the quality of education. So we need to keep updated ourselves, and that's why this particular activity, this particular exercise is being carried out. So once again, welcome. I welcome you all, and our Pro Vice Chancellor, Sir Professor B.V. Pawar, as well as Director of the school, Professor S.R. Kolle, and the resource person of this session, Shri Tendulkar, Ashish Ji Tendulkar. He is also with us, and I welcome you all. The maximum limit for this particular FDP, which is given by AICT, is 200. So we have all 200 participants registered. Then we have approved all these 200 participants, and till yesterday, 125 participants have communicated that they will join the course, and eventually they will join the course. So it's a good response. And as we all know, the instructions are given on the Atal website also, Atal portal also, that the 80% of attendance is compulsory for this course, and then and then only will get the certificate. So we are going to track the attendance in this Microsoft Teams. Then there will be a test in the last session, the 15th session, and you have to score minimum 60% so that you will be eligible to get the certificate. Then your feedback is essential, and on the last day you have to fill up the feedback on the Atal portal. So for all sessions, and you have to give the feedback. So therefore we will be providing you a Google form also, where you should give feedback every day regarding the sessions. And on the Atal portal also, you have to fill the feedbacks. Unless you fill the feedback, you won't get the certificate. So that's the case. So everyone has to give the feedback on the Atal portal, as well as on the Google form that we will share you in the last session. The brief idea, I already shared the schedule, tentative schedule, and we have invited very good resource person, and we're going to start with as we all know, Tendulkar is always gives us a good start. We are habitual, we are very fond of cricket, and we know Tendulkar always give good start for us. So we have a very good resource person, Ashish Ji Tendulkar, from here, from Google, and he will start. And we have very good industry resource persons again. In next 5 days, we have given a practical oriented approach, so you will see some practically how we can do the data science. Today I was reading a news that last year most of the patents, large share of the patents, was on data science and machine learning. So we are on a very area where it is like it's more sort of. So that's a very good initiative that we all have taken. So I hope you will enjoy these all sessions. And 3 sessions every day. You all know the timetable. 5 days, so 15 sessions. The last session will be a valedictory session. And I appeal to you all that it should be a proactive one. So be interactive. So we have given we have given all privileges to you that you can speak on. You can start your video also, so that we can take photos in the last minutes of the session. And then we will have we will form a cohesive group. It should be a sort of, this particular faculty development program should form a cohesive group of all scientists, research scientists who are working in data science, and that we should get some concrete out of it. So this is what I think at the as a preface of this particular workshop. I welcome you on the our campus is also good. Maybe next time we can have a offline sort of faculty development program, and you all can visit our campus, Kavitri Bainawai Chaudhary, North Maharashtra University. So I welcome you all, and I wish that this faculty development program is very useful, very fruitful to you all. Thank you very much.
Thank you, sir. Today we have with us Professor S.R. Kolle, Director of the school. I request him to give brief information about the School of Computer Sciences, KBC NME Jalgaon. Kolle, sir.
Very good morning. Am I audible?
Yes, sir.
Chief guest of this inaugural ceremony, Honorable Pro Vice Chancellor, Professor B.V. Pawar, inaugural speaker of this Atal FDP, Dr. Ashish Tendulakar from Google Research, coordinator of this FDP, Professor M.R. Joshi, who is also head of Department of Computer Science at School of Computer Sciences, deputy coordinator of this FDP, Dr. Manoj P. Patil, who is a faculty member in School of Computer Sciences, my colleagues from the school, and dear participants. At the outset, on the behalf of the organizing committee, I welcome you all at School of Computer Sciences, KBC NMU Jalgaon, for this FDP on data science. Let me apprise this hour's gathering that we are blessed with our scholarly and dynamic leadership in the form of our Honorable Vice Chancellor, Professor E. Vayunandan. We are grateful to our Honorable Vice Chancellor and Honorable Pro Vice Chancellor, Professor B.V. Pawar, for their constant encouragement and moral support in organizing such events. Friends, the School of Computer Sciences was formally established in 1994. Formerly it was known as Department of Computer Science, now offering 3 postgraduate full-time programs, MCA, MSc Computer Science and MSc Information Technology, along with PhD programs in the relevant fields. Our faculty members are engaged with research in different areas of computer sciences like natural language processing, image processing, information retrieval, web mining, etc. Our research is duly acknowledged by UGC, and UGC has identified our school under its prestigious Special Assistant Program known as SAP DRS2 for thrust areas like natural language processing, image processing, and information retrieval. We have been organizing various conferences, seminars, workshops, FDPs, along with certificate courses specifically on these thrust areas. In continuation with this, we are organizing this FDP on data science under AICT Training and Learning Academy. Dear friends, today as we know that this field, data science, is very popular area in field of computer sciences and which has widespread applications in the industry. We are extremely thankful to all the experts who have accepted our invitation to guide academicians and researchers participating in this FDP. We are thankful to AICT New Delhi for their generous financial support for organizing this FDP. Friends, I am confident that this course will give you an opportunity to gain expertise in one of the most fast-growing field of computer sciences through this online FDP, which will cover core as well as compelling topics related to fundamentals of data science and its applications in various areas. It will give the participants a rigorous and basic foundation in data science. Once again, I appeal you to grab this opportunity to enhance your knowledge about the field data science through your active participation. My best wishes to Professor Manish as well as Dr. Manoj for conduct of this FTP. Thank you all. Over to Dr. Manoj.
Thank you, sir. We have with us Professor B.V. Pawar, Pro Vice Chancellor of the University, and he is a senior professor at our School of Computer Sciences. Sir headed the School of Computer Sciences from foundation of the school. I request Sir to inaugurate FDP on data science and enlighten the audience with his precious words. Pawar, sir.
Good morning. Am I audible?
Yes, sir.
Okay, thank you. Very good morning to all. Inaugural speaker of this Atal FDP, Mr. Ashish Tendulakar from Google Research, Director, School of Computer Sciences, Professor S.R. Kolle, Coordinator, Professor Manish Joshi, Deputy Coordinator, Dr. Manoj Patil, all the faculty members from the school and dear participants. I take it as a great pleasure to address this August online gathering at this 5 days Atal Faculty Development Program focused upon data science. On behalf of Kavaitri Bainabai Chaudhary, North Maharashtra University, Jalgaon, and on my own, I welcome all the eminent resource persons, faculty members, and research scholars associated with this important academic development program, and declared that this 5 days Atal Faculty Development Program on data science is inaugurated and open. Friends, looking to this initiative, I'd like to congratulate Atal Academy for providing the platform to plan and execute such visionary academic training programs for the faculty members, teachers, and research scholars of our country, and sponsoring FDPs like this. Our university is accredited with A grade, having 3.11 CGPA in the year 2015, and very soon we are going for the fourth cycle of re-accreditation process. The campus of this university has been beautified with the massive plantation drive of more than 2 lakh trees, which earned Vanasri Award in 2000 by the government of Maharashtra and Indira Priyadarshini Vrikshamitra Award in 2002 by Ministry of Environment and Forest Government of India, New Delhi. The university imparts its education through 4 faculties, namely Science and Technology, Commerce and Management, Arts and Humanities, and Interdisciplinary Studies, covering various UG, PG, PhD programs on the university campus as well as in the affiliated colleges. We have on our campus 13 schools and 1 institute imparting education in 7 undergraduate, 48 postgraduate, and PhD programs. The campus is equipped with many modern amenities required for the present education system. Though we are meeting online today, I do invite all of you to visit our campus sometimes in the near future, as mentioned by Professor Manish Joshi. I am impressed by the overwhelming response for this FDP. Couple of months back, the school has conducted similar Atal FDP program on the theme artificial intelligence, and this theme of this FDP data science is online with the international and national priorities. The learned veteran experts would throw the light on the different aspects of the data science, which will help you to get better depth in the understanding of this important subject. On this occasion of the inaugural function, I extend congratulations to the Professor Manish Joshi and Deputy Coordinator Professor Manoj Patil, uh, who are uh, who are going to coordinate this FDP, and their team for coordinating and taking initiatives to offer the opportunity to the faculty members, teachers, and research scholars to discuss and learn about one of the important field in the science and technology. On this occasion, I would appeal all the participants to effectively engage and use all the opportunities which are provided by this FDP. I give my best wishes to all the participants and organizing team of this FDP to achieve the grand success. Thank you. Thank you very much.
Thank you, sir, for enlightening us. Thanks to all dignitaries for sparing their valuable time. Without spending time, we'll start our first session. For this session, we have with us Dr. Ashish Tendulakar. I request Professor Manish Joshi to introduce Ashish sir and start the session.
Okay, so we all will start the business right now. And as I said, the inaugural speech will be given by Ashish. Ashish Tendulakar is working as a research scientist at Google Research, and he was assistant professor in IIT Madras for many years. He taught there various subjects, basically in particular about machine learning. And then he has 20 years of experience of working in machine learning. And he has written multiple papers. He has many papers at his credit, and he is a resource person who has scripted courses on NPTEL, and he has taught popular NPTEL courses on practical ML with TensorFlow. So we have a very eminent personality with us. I request Ashish to start his presentation. Thank you, Ashish. You can start.
Thank you very much. Good morning to everyone. Can you hear me? Am I audible?
Yeah, we can.
Okay, sounds good. Okay, so what we'll do is, I'll share my screen quickly. Is there a way to share the screen? Okay. Let me share the screen. Okay, I'll switch off my video and I'll keep my screen. Okay, can you see my screen? Can everyone see my screen?
Yes.
Okay. Briefly about machine learning, and I will introduce machine learning to all of you as part of this session. Okay. At any point in time, if you do not understand anything that I'm talking about, or if you have questions, feel free to interrupt me. Okay. And I do this in a traditional style. I don't carry any slides generally. I like to develop things as we talk. So, I have considered this as a whiteboard, and I'm going to type in this Google Doc. So today we are going to talk about what is machine learning, how is machine learning and programming different, then applications of machine learning, components of machine learning. We'll play briefly with machine learning in the browser. We'll talk about a bit about overview of machine learning algorithms. And if time permits, we'll get into linear regression, implementation from scratch, and briefly talk about some machine learning tools like scikit-learn, TensorFlow, Keras, and PyTorch. Okay. Okay, so getting started right away. What is machine learning? Anybody wants to have a go at it? What is machine learning? Yes, anyone wants to talk about machine learning? What is machine learning? All right, I will talk about it. So in machine learning, we basically want to impart knowledge to machine, right? It's very abstract. Impart knowledge to machine so that it has human-like intelligence. That's a very high level, that's a very lofty objective, right? So what does it concretely do in practice, right? So I will take an analogy of computer program. All of you are writing computer program, right? I'm assuming that all of you are familiar with computer program. So let's say write a computer program add two numbers. Can you write a computer program for this addition of two numbers? Yes, many of you will say yes. What is this? And this is very simple. We can do it. So what happens in writing adding two numbers? So basically we're writing a function, something very simple, let's say in Python or in C, whatever, right? Whatever is your language, developed language. You can write a function like this. So let's say define a function add numbers. We give two numbers as input, and we simply say return a plus b. Correct? So what is happening here? So we basically have this situation. So we have, let me draw it just like how we draw on the board. So this is our program, computer program. So add numbers. So it takes two inputs. A and B. Is A and B are two inputs, and this is A, and there's another input B, and what you get is the output, right? You get an output which let's call it a C. Let's call it a C. The output C. Okay, this is the situation, right? Is this clear? Up to this point, this is pretty straightforward. We have done something like this. Now let me give you another task, a very simple task, a bit difficult task now. So let's say that the program detect number from an image, or to recognize number from an image. Simple task. Handwritten number. Let's say number is handwritten from an image. Can you write a computer program for this? Can you write a computer program for this? Yes or no? Can you write a computer program for this? Come on, you have to participate, otherwise the discussion will not make much sense. Can you write a computer program for this? Answer is binary, answer is simple, either it is yes or no. And no answer is wrong. Right? So images are something like this. Let's say this is one image, this second image. So these images are given as inputs to you. And you are supposed to write a computer program that takes this image as an input and predicts what is the digit which is there in this image. Can you write a computer program for this? Yeah, some of you will say yes, we can write the program. So people who say yes, they will say that we will use certain rules, right? Or heuristics. And write a program will take digits. And others will say no, it is simple function. I mean, yeah, you can definitely use some rules and write a program to detect digits. And people who are saying no are also right, because we cannot write. We can't write so many outputs. So many outputs. Right? So look at the way things are written, right? Somebody writes 6 like this, somebody writes it in a different way. See how 5 is written. 5 is written like this. It is also written like this. 3 is also written in different way. 1 is written in different ways. Right? So there is a variety in which these digits are written in the image. And writing a computer program to detect these digits seems like a difficult task. Correct? Do you appreciate this? Do you see the difference? Now let us try to take a step back. And what we'll do is, we'll try to identify the differences between two tasks. You will find standard definition of machine learning in your textbook. I'm not getting into it. What I found in my teaching experience is some such way of introducing machine learning resonates well with people who are familiar with programming. Because people know how to write programs, and people want to have some anchoring, right, to understand machine learning. And that anchoring, if done in programming, helps people to understand machine learning better. So now my question is, let's try to spot difference or differences between two tasks. What are two tasks? Addition of two numbers and recognition of digits. And I asked you to write computer programs for this task, right? So what are the differences? Can anyone tell me those differences?
Please attending to this school is
Yes. Yes. Yes, somebody has Sudashi. Yes. Please go ahead, Sudashi.
Sir, sometimes your voice is not.
My voice is not, you're not able to hear my voice?
Ashish, there are some messages like your voice is trucking, not coming clearly.
Is that so? Is it better?
Yeah, this is better now.
Okay, now okay, now.
Okay, so is there any question?
Sir, you can go.
Is there any question so far? No questions? Okay. All right. So, what is the difference between these two tasks? I have a question for you. Can anyone try to answer this question?
Excuse me, sir.
Yeah, please go ahead.
Sir, chat box is not visible, and I have a query, sir.
Yeah, please go ahead. Please go ahead.
Sir, which tool you have used to perform this program?
Which? What is that?
Tools or programming platform?
Manish sir, can you answer this? I don't know.
Okay, sir, I will try to write in chat box when it will be visible.
Is this query about what I'm talking about, or is it in general about course?
Sir, I'm talking about this session.
Okay.
You have right to program addition of two number. And what kind of tools you use to support this program?
Yeah, you can use any programming language. You can use Python, you can use C++, you can use Java, any programming language. That is not a problem.
Okay, sir. Understood.
Yeah.
Okay, sir.
Yeah, no
Thank
problem.
you, sir.
So what is the difference between these two tasks? And that will help us get into machine learning. So you can see that addition of two numbers is totally easier to do, right? Easier to do. And why it is easier to do? Because we know the mathematical function to add two numbers, correct? We know the exact mathematical function. Two numbers B, we can just do A plus B and we get the sum of two numbers, correct? But in case of the second problem, we do not know exact mathematical function that takes image as an input and return the handwritten digit. Right? That is the problem, right? Correct? So here we know the mathematical function. This is the important part. And here we do not know the mathematical function. Alright, so that's why we find second task a bit harder to write in computer program right now. But as a human, can you recognize these digits? Can you recognize these digits as a human? Yes, all of you can recognize these digits, right? Correct. So why? Why are you able to recognize these digits? Human? Yeah, because we are trained to recognize these digits. We introduced these digits in our school days, and since then we have seen so many of these digits, so many variety of these digits, that we are able to recognize these digits, right? In whatever form people write them, we are still able to recognize them, correct? So now, so basically we are trained to recognize these digits. You experience training. Right? Now, can you do similar training of computer? Right? So question is, can you make lots of such images available to the computer along with the labels? And what are the labels here? Label is the image itself. The what kind of digit is present is the label, it is the image, right? Along with the labels, correct? And train it to recognize. Right? Are you getting what I'm talking about? You're slowly entering into machine learning. Right? So this is something, this is machine learning, learning from the experience. So we are presented with a lot of images along with their labels, and we are trying to learn from these images what kind of labels are they. Correct? So, so these experiences is for what is called as training data of machine learning. Right? So what does training data contains? Training data, what does it contain? It contains data and labels. Correct? And data in this case are images. In this case, it's images. Getting it? You can take other examples. Let's say whatever city you are staying in, let's say you are in Jalgaon, and you want to find out, price of a land in Jalgaon. Correct? How can you find the price of land in Jalgaon? Right? Price of the land varies based on its location, based on various amenities or various access points that are available with the images, right? So how can you learn the prices of the land? So basically you need some kind of a training data where you have land and its attributes, right? What are the attributes of the land? Area of the land, location, right? Distance from river, water source, bus station, right? Railway station, railways, school, hospitals. Right? You can come up with many such kind of features. Right? Whether it's agriculture land or not, agriculture or not. You can come up with many such kind of attributes of the land and its price. Right? So this is also training data. This training data is used for learning the price of the land based on its attribute. Getting it? So is training data is the most important components of machine learning. Now repeat after me. No data, no ML. If you don't bring training data, we cannot do any machine learning. Getting it? This you should remember. Even if you forget everything else, that is fine. But remember that no data, no ML. If you do not have training data, we cannot do machine learning. Getting it? We have not seen what else is there, but just remember that training data is the most important thing. Okay. Is this clear to everyone so far? So far, so good?
Yes, sir.
Yeah, any questions?
Yes, sir.
Okay, no questions, no problem. Now let's try to understand how machine learning works. So let's draw a sketch of machine learning, right? Let's draw a sketch. Now, yeah, please mute yourself if you are not talking. That will help others to focus on the discussion. Now, this is machine learning. We'll see what is there inside this later. What is the input to machine learning? The input to machine learning is data. Yeah, please mute yourself. There is some noise that is coming from someone. There is
Dr.
data.
Kamal, please mute yourself.
Yeah, that will be good. Thank you. Your data and label are inputs to machine learning, and machine learning produces what is called as model. And we get a model, and we'll see what model is in a minute. Right? And what we'll do is we'll contrast this. We call it as a model, or we'll also call this as a mathematical formula. Right? And now contrast this with programming. Is your computer program. It takes data and formula as input, and it produces label or output. Are you clear? Are you clear about the difference between these two parts? This is the most important takeaway from these 15 minutes. So how the machine learning and computer program differs? Machine learning takes data and output as input, and it outputs mathematical formula or model. Whereas computer program takes data and formula as input and it produces output. So in case of our example of adding two numbers, data is B, formula is addition of two numbers, right? A plus B is the formula, and you get the output, which is addition. Getting it? Any questions so far? Any questions so far?
No, sir.
All clear?
Yes, sir.
Okay. Let me move forward. Now, what is model, right? Let's try to talk about. Let me first talk about components. Okay, let's first talk about model. What is model? Model is basically, you can think about this as a mathematical formula. So the simplest model that you know is probably model of a straight line, right? Equation of the line, as you have studied in high school, right? Which is, anyone remember equation of the line? Yes.
Y is equal to mx plus c.
Great. Y is equal to mx plus c. This is equation of the line, correct? And what are the parameters in this model? I'll write this slightly differently. I'm unable to machine learning for y is equal to, I'll say w1 x plus W0. Okay, W0 is C and W1 is M, correct? So in this case, M, which is slope and intercept, are two parameters, correct? These are two parameters, right? These are two parameters of the model. Okay, so what happens? So whenever you want to learn line, we need to estimate these parameters, correct? But the way we have studied this in high school is, if you give me value of M and C, I can draw a line, correct? Getting it? In high school, right, given value for M and C, we can draw a unique line, right? Okay. So now the equation of line is the basic model in machine learning. Okay. It goes by the name linear model. You must have heard about linear regression. One of the example model is linear regression. And in linear regression, we are trying to predict y, which is output, as W0 plus W1, X1, W2, X2, so on, Wm, Xm. Now, what are these X1, X2, Xn? You might be wondering, what are these, right? So in this formula, y is the output, X1, X4, and all the way up to Xn are attributes or inputs. Getting it? So I was telling you about finding price of land in Gargaon, right? And we were talking about different attributes. So these are inputs. And W1, W2, all the way up to Wm are weights or parameters of the model. And what is this equation? This is equation of a hyperplane. Okay, which is generalization of line in n-dimensional space. Equation of hyperplane in n+1 dimensional space. Getting it? So I mean, if you want to do this as a line, right? If you want to learn. Okay, so if we just do this as y is equal to W0 plus W1 X1. What is this? This is equation of line with two parameters W0 and W1, right? And X1 is the input and Y is the output. See what you see here right now, the suggestion, this is an application of machine learning that is in action. So it is suggesting me that instead of writing is equation, it should be is an equation. This is machine learning in action, just for your information. Anyways, So do you understand this? This is an equation of line, right? So this is a model which has got just two parameters, W0 and W1. Okay. And Y1 and X, Y1 is the input, sorry, Y1 is output, Y is output and X1 is input. So we are given basically as an experience. So what is our task? Our job is to learn the parameters of the model. Right? You see, machine learning is not still powerful enough to learn the model itself. Model is something that is given by the designer of the system or by the architecture of the system. And specified model has got multiple number of parameters. And this parameters is something which is learned by the model. Our job is to learn parameters of the model. In this case, we have to learn W0 and W1. How? Using experience or the training data. Basically, by experience, I mean using the training data that is provided to us. So far, so good. Let's look at one concrete example of a training data, right? How does it look like? So let's say this is x1 and this is y. This is things here 3, 2, 4, 6, 8, 15, 25, 31, 9. And output, I'm constructing something. 7, 5, 8, 16, 9. Okay. So let me put this on a new page. So let's say you are given training data like this. It has got x1 and it has got y. This is how the training data will be literally. Any question about this so far? Do you have any question about this? And now from this, and this training data is for learning model y is equal to W0 plus W1 x1. Now, what is your hunch about the values of W0, W1 by looking at this? What do you think are the values of W0 and W1 by looking at this? Anyone? Anyone? What do you think would be value of W0 and W1? Do you see any pattern of value of Y? How is it related to value of X1?
It's 2 and 1.
Oh, that's a good idea. What is 2 and what is 1? Y is equal to 1 plus, what is 1 plus 2x1, right? Is this how you mean? Is this what you mean?
Yes, yes, sir. W1 is equals to 2 and W0 is 1.
Makes sense? Makes sense. It will work in most of the cases, right? Let's check it out. It will work here. Let's substitute x1, the value of x1, 3 into 2, 6 plus 1, 7. 2 into 2, 4 plus 1, 5. 4 into 2, 8 plus 1, 9, but it is 8. So there is some error that we will make on this example, which is okay. This is matching 6 to 12 plus 1, 13. It is having some error over here. It is having some error over here. This is matching perfectly. Some error here and some error here. Getting it? But more or less, W0 will be 1, 0, and W1 will be 1. Make sense? Any questions on this? Any questions on this so far?
Sir, can you explain the training data equation, sir? Y is equal to W0 once again.
Yeah. So let me actually, do something else now. So this is one platform called Collab where we can write some Python code as well as libraries. So let's try to do something. Let me do this. What are the values that we have taken here? 3, 2, 4, 6, 2, 3, 4, 6, 8, 9, 2, 3, 4, 6, 8, 9. 3, 4, 6, 8, 9. 5, 7, 8, 13, 16, 18. I'm doing this purposefully in front of you so that you feel that this is something which is doable. Okay, this is not what is difficult. This is doable. 51, 62, 20, 51, 62. Okay, let us run this code. This will fail, obviously, because we have not yet defined NP. Let us run this. Yeah, please keep yourself on mute if you are not talking, okay? It will not disturb others. There are some participants whose mics seem to be on. Okay, so now we have done this. So let us quickly check the shapes of these two arrays. I'm just making sure that both of them have 9 elements. And what we'll do is we'll give a plot. We'll do it like this. So see, this is the situation, right? This is the situation that we are in. Are you getting what I'm saying? Now we said that we are going to use line, correct? We are going to use one of the lines. So what line will fit most of these points? What kind of line, if I draw, will fit most of the points? Correct? So let me actually this is x1 and this is y. So this was our guess, correct? Our guess that W0 is 1 and W1 is 2 is purely by guess, correct? By looking at these examples. Getting it? So that's why we have chosen 2 and 1. And ideally, you can actually plot them. Here we can plot them because we just have one attribute. But if you have tens of hundreds of attributes, you cannot even plot them. But But looking at examples in a lower dimensional space helps you to get intuition about what is happening. Okay. So we need to have something, right? So we talked about training data. So we need to have training data like this. And based on this training data, we want to learn these parameters. Now, question is, how do we learn these parameters? How do we learn these parameters based on training data? Is the question. How do we learn these parameters? Here. Right, you can try different values of W0 and W1. Correct? Now
Sir,
there
we are able to see only this Google Colab screen, sir.
Ah, okay, sorry. I will share this. Can you see my screen again?
Yeah, now I'm able to see the document, sir.
Yeah, documents. I mean, how do we learn these parameters from training data is the question. So there are two unknowns, correct? W0 and W1. Right? And our job is to find W0 and W1.
Sir, what are W0 or W1, sir?
W0 and W1 are parameters of the model, right? These
Okay,
are W0 plus W1 x1 is our model. So W0 and W1 are parameters of the model, and we need to find out values of W0 and W1 such that which values would be good values? Anyone? Which values will be preferred for W0 and W1? You can put any values for W0 and W1, right? And putting any values over here is going to give you a line, correct?
I think Ashish, your mic is mute. Hello, Ashish.
Hello, can you hear me?
Yeah, it's okay now.
I think it got muted.
You muted yourself, I think.
Yeah, I think I muted myself. Yeah. So if I change the values of W0 and W1, I can draw different kind of lines. Do you get that point? Or not really? Let us try. Let us plot more lines like this. Okay. And see that it really works. Okay, so what I will do is I will go back to Colab again, and let me share this screen. And here we'll put some values for W0. W0 is 1 and W1 is 0.5. And we get the value of Y predicted is equal to W0 plus W1 into X. Okay, we have got X1. Okay. And you see, we got some value for Y predicted, right? We got some values. Now what we'll do is, we'll plot a line here. Right? So also plot. You see this? So this was our input, this is our input, and for this input, these are actual values, and because we use some values of W0 and W1, we got this line. Getting it? Let me write the label also here, which is 1 plus 0.5x1. Okay, so we got this one line. Now, what I will do is, I change the values of W0 to let's say 10 and W1 is 0.5. And let us call this as spread 1. You get some other values, right? Now let us plot this. Let's call it as spread 1. And let's make this as a blue line. And this is, we just change the value of W0, we made it 10. And let's see what kind of line we get. Okay, is this a good line for this data? Is the question. Huh?
No.
It is not, right? Good. Now let us try what we guessed, right? And let us plot that line. What do you see? So we have 3 models here, and model is parameterized by W0 and W1, and there are different values of W0 and W1 that we try, and we get 3 models or 3 lines. Which line is better? Anyone? Which line is better?
Green is better.
Green line is better, right? And why green line is better?
Covers most of the data points.
Huh?
Connects linearly all the data points.
Yeah, it basically, so if you take the data point, the value that you predict is the point on the green line, right? And the point, the actual point, they are close by, correct? So such that, so we have to find W0, W1 such that the predicted map, the predicted value matches the, or the predicted output matches the actual output. Getting it? Getting it? Okay. So how can you talk this in, how can you say that in math, in terms of maths? So let's say y pred is the predicted output minus y is the actual output. Is the difference, correct? This is the difference in the outputs. If you take this difference as it is, there will be plus and minus signs, right? So in order to get rid of plus and minus sign, we basically we take square of this. So let me come to Colab and write this. So we want W0 and W1 such that right? We want W0 and W1 such that y hat, which is the prediction, matches the actual value closely. And we can write this in mathematical form as follows. We take square of the difference. Getting it? We take square of the difference and make sure that it matches correctly. So this gives you the difference. Let's say ith point. This is your ith point, for example. The prediction for ith point, correct? So this should match closely, and we basically sum up this over different points. Let's say we have n points, so we sum this up over n points. Getting it? This is called sum of squared error or SSE, right? And this is called as loss function. This is the loss function in linear regression. Normally, sometimes you will see people normalizing this by number of data points. This is average sum of squared error. Getting it? And this is denoted normally as J, and it is function of W0 and W1. Getting it? And how it is function of W0, W1? Let us check it out. I hope this is clear to you so far. If you have questions, happy to take them.
I think this hat is like just you mentioned for prediction. Why prediction? You just make it a hat.
Yeah. So why this is the predicted value? No? So I'm going to tell you how this value is computed. Okay.
Okay. So just to mention that why prediction, you mention it hat.
Yeah. Prediction is mentioned as hat. Correct.
Okay.
Sir, can we have a different loss function, or only we can use this?
You can have different loss functions, right? Depending on what problem you are solving. I'm just showing you one loss function that is appropriate for this case.
Okay, sir.
Okay. So do you see why J is function of W0, W1? So we get a prediction by substituting the formula for prediction, right? So what was our model? I'm just going to talk about our model. Our model was y is equal to W0 plus W1. This was our model, right? So what I did is I simply substituted this y predict as W0 plus W1 x1, and this is ith point, by the way. This is ith point, x1 value of ith point, and this is the predicted actual value of ith point. Getting it? Right? Everyone with me so far? So now we have to find W0 and W1 such that J of W0, W1 minimized, correct? You're getting what I'm saying? Now you have to find W0 and W1 such that this loss is minimized, correct?
Yes.
So how can you find these values of W0, W1? Right? one possibility is that you can, okay, now let's write that question. What options do you have? Try different values of W0 and W1, and for this pair get the value of getting it? And this is the value of error or loss. Will this work? Will this process work? Procedure work? Are you getting it? I have two-stage process. In stage 1, we try different values of W0 and W1, and for each pair, get the value of W0 and W1. Sorry, the value of J of W0 W1, which is its function, and choose W0 W1 that result in the least error or loss. Will this work? Is this guaranteed to find the actual values of W0 and W1? Are you getting the point? We are not talking anything complex. We are talking some simple things. I'm taking a pause. Do you have any questions? This is fundamental. Do you have any questions?
Ashish, we have to decide what is mean by minimum also, no? Then in that case.
Sorry, we have to define what?
Minima is what is our minimum threshold, or what we can say it is minimum.
It should be as close to 0 as possible. That is the minimum, right?
Yeah. But like the threshold also we can define in that case. If I say
we can define a threshold, but it should go close to 0. But see, here it is not possible to get exact 0, right?
Yes.
Because there are some points which will always be outside. If you use such a simple model, right?
Yeah.
So threshold. So this process will not work. It is not guaranteed that the actual value of W0 and W1, which is 1 and 2, they may not be there in your set, right? So this process may not work. And how many different values of W0 and W1 will you try? So this brute force search will not work. So we need to do something more principled. We need to do something more thorough. What is that? What is the alternative approach? Yes. Anyone has any ideas? Yes, what is the alternative approach? Do you remember 12th grade calculus and applications of derivatives? We are going to use exactly application of derivatives here. So you can find out minimum of function through derivative, correct? Do you remember this? We can use derivatives to find minimum of the function. Getting it? And which function are we trying to minimize? Your function. And in this case, minima of loss function. So how do we find what happens at the minima point? The derivative is 0, right? So what we do is we take the partial derivative. In this case, there are two variables, right? So we take partial derivative calculate this and we set it to 0. In the same manner, calculate partial derivative of and set to 0. Okay. Is this clear? Is this clear to everyone? Now I really need questions from you because I don't have much idea about what you are getting and what you are not getting. So if you have questions, happy to answer them at this point. Yes?
Yes. Sir, you are writing this.
Huh? Go ahead. What is the question?
Why partial derivative, sir?
Huh?
Why partial derivative?
Because we assume that variables are independent of each other, so that's why we are taking partial derivative. Getting it?
Yes, sir.
Okay. So, any other questions? Any other questions? So now I will bring up some visualization. I'm just trying to get it on the board so that I can show you something very interesting. Give me a minute. I'm getting the visualization. Okay, can you see my screen? Can you see my screen?
Yes, sir.
Yes, sir.
With visualization?
Yes, sir.
On your left, what you see is the loss function. Is you see a loss function that we have written precisely, which is sum of squared error, right? The loss function looks like a bowl-shaped loss function. So you know it is just written like a bowl, and basically the bottom of the bowl is where the value is minimum for this loss function. Getting it? Now our point is over here. So we have chosen this line that you see on the right hand side, and for this line basically represents a point in the loss space because we have values of W0 and W1, and for each one of W0 and W1 we have value of loss. So this is the current loss. Now what I will do is we will slide this point. See, as we slide this point, you see different line appearing, right? And as we move towards the bottom of the bowl, you see that the loss is going down, and as loss is going down, line is also moving close to the line is also moving close to the actual point. So you see that this is where the loss is minimum, possibly around this point. So I'm just trying to get the line closer. You see, and here you see different values. This is the value of the loss, and this is the value of W0 and W1. So you see that we have currently pretty much perfect line with zero loss. And as you move away from this bottom, you get very weird types of lines. Getting it? Yeah, you can see that as I move away from the bottom, the loss increases, and you can see that the fit is also not perfect. Do you get the intuition of this? Do you get the intuition? These are loss function looks like, and this is your model, and your model is actually a point of the loss function. So you have to find a point on the loss function such that we get the least error, and values of W0 and W1 corresponding to those points will get us the optimal model, right? The model that results into the least loss. Okay, are you with me so far?
Ashish, this
Yeah.
on that graph, the third value is the loss.
Yeah, third value is the loss. Exactly. Third value is the loss.
Okay.
Third value is the loss. As we move away, our loss goes up. You can see that as we move away from the point, the loss goes up.
Yeah, it's a good visualization.
Yeah, it's a very interesting visualization. So,
yes.
You know, I'm actually teaching this online BSc course, IIT Madras, and for that we have created this visualization. I thought this would be useful for participants to see this visual.
Yeah,
this is very, very fundamental.
It gives insight also, like.
Yeah, it is very insightful. You see that the model is actually a point of the loss function space, and that is very clear from this visualization. And as you slide this, you can see how the loss changes and how the model is fitting. Getting it? Yeah, so I thought this is useful and important. Right, so this is what we did manually, but we actually use an optimization procedure for that. And you must have heard the name called gradient descent, right? So gradient descent is an optimization procedure. So now what we'll do is we'll just list down components of machine learning model. So you take any machine learning model, rather machine learning algorithm. You take any machine learning algorithm. It has got the 5 components. The first component is calculator. Second component is model. You have seen what model is. The model that we saw was line. Then third one is loss function. So we need to have a loss function, and we minimize this loss function into what is called as optimization procedure. And mostly gradient descent works here. So you can say gradient descent as an optimization procedure. Loss functions could be different. We have sum of squared error. For regression, we have binary cross entropy loss. For logistic regression or for a classification problem, we have hinge loss for SEM. These are all loss functions. Okay. Then we have linear models and logistic models, logistic regression. We have SEMs. These are different models or neural networks. Other models or decision trees. These are models. You will probably learn them in this FDP, but I'm just telling you what fits where. And training data, you know, we need to give features or attributes and labels. Getting it? And the final component is called as evaluation procedure. Model selection and evaluation. How do we really evaluate machine learning models? Getting it? These are 5 components. You take any machine learning algorithm. If you ask these 5 questions, picture will be clear to you. Like, don't get into any Mathematical details is something that you can learn. That's not a problem. But try to understand the big picture of the algorithm by asking these 5 questions. What is the training data? What is the model? What is the loss function? What is the optimization procedure? And what is the model selection evaluation? And I'll show you how this works, right? I'm not showing you exactly what gradient descent does, but gradient descent basically automates what we are trying to do manually by doing trial and error, right? So gradient descent automates that particular thing using partial derivatives, right? It's basically application of derivatives. Getting it? And for want of time, I cannot get into details of this. Otherwise, I would have loved to look at, explain gradient descent. I have YouTube videos on gradient descent. You can check them out. I think gradient descent has been explained very thoroughly over there. It's an NPTEL video on TensorFlow. I guess video 8 or 9 is about gradient descent. You can check it out.
Okay. Like Ashish, I have a question. Like this model selection and evaluation at last you have. Basically, we decided that the fourth one optimization process and in the loss function, we decided that we'll have a minimum loss. Then what is that last point again? That model selection and evaluation, because
yeah. So what happens is that we just saw a very simple model, which was regression model. But sometimes there are complex models, and they are what is called as hyperparameters, right? So hyperparameters are basically some kind of configurations that the model architect sets, right? And we do not optimize those hyperparameters explicitly. So for different values of hyperparameters, we get different models, okay? Even after optimization. And then our job is to select the model, the hyperparameter that results into the least loss or least whatever measure that we have of performance. And that's what we do in model selection. It involves what is called as hyperparameter tuning. Yeah, it generally involves hyperparameter tuning. And selecting the best model out of multiple models that we get after hyperparameter tuning. Yeah. It also involves selecting appropriate evaluation measures. For regression, for example, we use measure like sum of squared error. For classification problems, we use measures like precision, recall, F1 score, accuracy. So that also comes under this point. So this particular point broadly involves how model is evaluated, or if there are multiple hyperparameters, what kind of hyperparameter tuning has been applied, which is part of model selection. Is that clear?
yes.
Yeah. Okay. We have another 20 minutes. So what I will do is, I have listed many points here. I will quickly give overview of machine learning algorithms. We may not have time for these two, but I will actually show you first these machine learning problems in browser. Probably you will get overview later of machine learning algorithms. Basically, there are two types of algorithms. We will quickly go over them. So now label, based on label, there are two parts, right? One is regression, where label is a real number. And second is classification, where label is a discrete quantity. So for example, you have problems like which involves yes, no, correct? Output is either yes or no, or the digit recognition problem that we saw, which has got digits like 0, 1, 2, all the way up to 9. Right, so these are basically the classification problems. Within classification, depending on number of labels, we have two types of problem. If you have two labels, we call it as binary classification problem. Binary classification problem. If you have more than two labels, we have what is called as multi-class classification problem. Getting it? And sometimes label is absent. Label is absent. Then we have what is called as unsupervised machine learning problem. And if label is present, we have supervised ML problem. So classification and regression are basically supervised machine learning problems. And there's one more technique called as reinforcement learning. which is beyond this, which is, I don't want to talk about it right now. And sometimes what happens is that label is present for a few examples and not present for many examples. That is called as semi-supervisor. Getting it? Huh? These are general types of machine learning algorithms. Now let me actually give you a very interesting tool. We can actually get good intuition about these machine learning problems in browser. Right? So this is called neural network playground. Do not worry about neural networks right now. So just have this setup. Very simple setup with zero randomness. And I'm just putting, and let's say select classification. Now your job is basically to learn. This is your data set. It has got two classes, blue and orange. And you need to learn a boundary that separates these two classes. Okay. You can generate this data. You can use some 80% examples for training and 20% for test or whatever. Right? And we have two features, x1 and x2. If you just use x1, you will get classification boundary which is vertical. If you just use x2, you get classification boundary like this. And now if you use both of them, what we are going to do is we will start training the machine learning model with very slowly, by using a very small learning rate. So you can see that the model is training. This is too small. I'll just make it a bit larger. You can see that the model got trained. This is the boundary that is learned. And after model is trained, the train and test loss is very close to zero. This is what should happen. And these are the weights that model has learned for these two parameters. Getting it? Now let's take slightly interesting situation, which is where we have two classes that are separated by a circle. Correct? Now let's use these two features and try to learn the model. So when I press this button, model is getting trained using gradient descent algorithm in the background. Okay. So you can see that no matter how hard we try, the loss is not close to zero now, right? Loss is non-zero. Training loss is also high and test loss is also high. So this means the model that we have learned does not have enough capacity to learn the decision boundary. And decision boundary here is circular in nature, correct? We are fortunate to visualize this because we just start using two features. But when we have very large dimensional data, if you see that training loss and test loss, both of them are high, that means our model does not have enough capacity to learn the function. So what we do is we add polynomial features. So we take x1 and we square up x1 and we get x1 squared. We take x2, we square it up, we get x2 squared. So instead of just two features, we are now using four features. Okay? And now we will again train the model. Train it very slowly. What do you see? We got a separator, right, which is a circle. Also look at the losses. Training loss and test loss are close to zero. So if your model is training nicely, see, this loss should go down after every iteration of your optimization procedure. And final losses should be close to zero. You can see a very nice circular decision boundary here. Getting it? And these two parameters are having high weight. Is minus 30, is minus 0.31. And see the weights that these two features got are very, very small. Isn't it interesting? Do you find this interesting? There is no magic. We are just trying to see what kind of features will be useful here. Got it? Yeah, so you can play with such kind of things. So I'm now including one more x1, x2, one more feature which is interaction term, and we'll try to see the prediction. Now you see the prediction also. We got this nice separation. If you don't include this feature and try hard, we don't get nice separation, right? You again see that training and test losses are high. That means we have less capacity in the model, so we need to increase the capacity. One way is to add interaction feature. So now you see nice separation. And which is the most important feature? It's interaction feature. It has got the highest weight. And the other features have got very small weights. Getting it? This was a visual demo of machine learning. And
Ashish, can we get the mathematical formula like we get for the model? Here we will not get the formula for that one, no?
I'll write a mathematical formula in the notebook here. I'll share this notebook. In this case, the mathematical formula for the model will be y is equal to 0 plus w1 x1 plus w2 x2 plus w3. Now we have got x1 squared. Plus, you can think about it. It's pretty straightforward. Now x2 squared w5 getting it? Your formula.
Okay.
This is your model, basically.
Okay.
And then right now we are using classification rate. The loss is different. It's called binary cross entropy loss. But if you can also do this for regression, and the loss will be the same. There is no change in the loss function. Loss is exactly the same. Only thing is that now the terms will be more. There will be more terms here. But the loss function remains the same for regression. We don't change the regression loss function. Getting it?
Yes, yes.
Yeah. And by the way, it's very easy to implement these things also from scratch. It is not very hard. I will just show you one sample of this. And unfortunately, we don't have much time, but I will just try to quickly show you how to implement these things. Literally one line code for each one of them. So I'll show you. Yeah, see, we implemented this linear regression class. And you can see that the predict is one line function. We have used what is called as vector operations. So x times w is the prediction. You get prediction for many examples all at once. Then loss function is also one line code in Python. This RMSE calculation is again one line code. And gradient descent is the gradient descent procedure that I have implemented. Yeah, so it is easy to implement things. And I'm basically showing all these things to you so that you don't get scared away from maths. Ultimately, implementation is pretty straightforward. It is one line code, literally. Yeah. I will actually stop here and take questions dedicatedly for 10 minutes because we have 10 more minutes. There are so many things to share, but I mean, we just don't have enough time.
Okay, we'll see if participants can have questions.
Yeah.
Okay, you can unmute yourself and ask question if you have any questions for Ashish.
Any questions? I mean, feel free to ask questions. No worries. I mean, no question is a stupid question.
Sir, where we can use TensorFlow, sir?
Sorry?
TensorFlows.
TensorFlow. Okay. TensorFlow is a library that is used for implementing deep learning, like neural networks and things like that. Normally, if you are implementing any of these algorithms in Python, you don't have to implement them from scratch. Also, you can use libraries like sklearn, where all these algorithms are implemented. You can bring in data set and use sklearn functions to solve the problems. And in the same manner, if you are doing deep learning, you can use TensorFlow, Keras, or you can use PyTorch.
Okay, sir. Okay. Thank you.
Ashish, generally in neural network, when we use, like we do not capture the knowledge, like the rules we generally get in any other way. So how do we specify rules from this neural network?
That's a great question. Neural networks, people are finding it hard to interpret neural networks right now. And neural network interpretability is ongoing research. So there are few things that people do to figure out why neural network is giving output the way it is giving, right? But it is still area under active research and they are not interpretable is probably the simplest answer at this point. Yeah, but sometimes what happens is that we want models that work better rather than being interpretable, and at that time neural networks work great.
So we focus on output rather than understanding it.
Yeah. And if you want basically equivalent of neural network, right? If you want the equivalent of neural network in something in linear regression, for example, right? You create massively polynomial models. We just created a simple polynomial model just now, right? We did x1 squared, x2 squared, x1, x2. You can add third order polynomial, fourth order polynomial, keep doing it. That will create a model which will have same effect as neural network, basically.
Oh, yeah. It's like a reverse engineering brain.
Yeah, it's more like reverse engineering, but it is not so straightforward. But you will get some idea about why.
Yeah.
I think they are like that.
All right. So any other question? It was like a very good session, Ashish. I followed you a lot, and it pays me off. Like the one very simple manner you explained, very difficult. Like we feel it very difficult concepts, and you explained it very well. Thank you for that. Any other questions?
Sir, which textbook you prefer for machine learning, sir?
Which books?
Textbook.
It's a very hard question. I generally do not. I mean, whatever I told you today is based on my experience and different classes that I take. Based on my interaction with students, I found that this way of introduction to machine learning resonates well with students. So, in that sense, I don't have any textbooks for recommendation. Uh, it's very hard. It's very hard to actually recommend any textbooks. Yeah.
Thank you, sir. Thank you.
Yeah, but I mean, one book that I really liked, and again, this is this five component approach that I talked about. It comes from the book by David Hand. It's called Principles of Data Mining. It's like a book, Principles of Data Mining, by David Hand. Check out that book. I really like that book and the treatment that David Hand gives to machine learning. David Hand. Hand, this is my hand.
Yes.
Hand.
Okay, sir. Thank you, sir.
No problem. Thank you. Any other questions?
Sir, tools those you have used for visualization. That is our question. And how we have created the to visualize particular model and that loss function specifically. Those visuals you have created, we want to understand that from which tools you have created to visualize. To visualize that loss function basically.
We actually use GeoGebra as a tool for visualizing that. There is a tool called GeoGebra that we use for breaking up that visualization.
Okay. Thank you.
And then in the background, we have written code in JavaScript to calculate all these loss functions.
Okay. Thank you.
Yeah. Any other questions?
Okay, I think all participants are okay. They don't have any questions right now.
Yeah.
So thank you, Ashish, on behalf of School of Computer Sciences of Kavitri Bainabai Chaudhary, North Maharashtra University. I thank you very much from bottom of my heart, and it was a nice, very nice session. Like as I said, because this mathematical functions, when it comes, it frightens us. So computer science people generally uh, just try to always use the tools without understanding it. So it generally it's good idea, and it the way you presented it is very innovative and very informative. Thank you very much. Thanks a lot.
Yeah. Thank you very much, Manish, for the opportunity to
Yeah.
interact with so many faculty members all at once. And I'm sorry to make you follow up multiple times. It's just that I couldn't answer
No,
you.
I understand. I understand you are quite busy. That's fine.
Yeah. So thank you very much. And
Yeah.
I really, I really recommend people to understand machine learning uh, from inside out, right? Rather than just using tools. That is my one line advice. And I have given you a toolkit with 5 different components. Always try to dissect machine learning algorithm with these 5 different components, and picture will be much clearer to you. Yeah. So thank you very much, and all the
So
best.
we have recorded the session, and all this session will also be there on the Atal portal,
Okay.
apart from your all NPTEL lectures.
Sure.
Thank you very much for the participants. Like we will join again for the next session at 12:30. So 12:25, I request you all to join so that we can have next session. Thank you very much.
Thank you. Have a great
Technically,
day.
yeah, thank you very much.